In example 5 of section 8.2, we're asked to tell whether each figure creates the conditions to form a unique triangle, more than one triangle, or no triangle. So in our first example, what you see here is that we have some side lengths or some rays here. We have a side length that's 8 centimeters. We have an angle that is a 45 degree, and that 45 degree angle is one of the sides of it is made up with this 8 centimeter side length. And then up here in the top part of this, right here, this part, when you see that little squared off area, that means that this is a 90-degree angle or a right angle. So in this particular problem, what we could do is we could have very easily dotted out our line like so, and then we would be able to create a triangle. So we're supposed to be telling whether this figure could either be a unique triangle, more than one triangle, or no triangle. Now, since you could extend this line out and it would cross and it would actually indeed form a triangle, we know it's not going to be a no triangle. So our other options are now that it's a unique triangle or more than one triangle. So in looking at this, we have this fixed side length of 8 centimeters. And that's 8 centimeters cannot be changed. Okay, it has to stay the same. So because of this fixed side length here, what we actually have is something called a unique triangle. We can only form this one triangle. We can't form any more than that particular one. Now, in our second example up here at the top right, we're given 3 side lengths. We have one side length that's 4 centimeters. We're given one side length that's 3 centimeters. And then we're given a third side length of 11 centimeters. So this type of problem is going to kind of revert back to those 3 criteria that we did in example 1, where the sum of A and B has to be greater than C. The sum of B and C must be greater than A. And then the sum of A and C must be greater than B. Now, if any of these criteria are not met once we assign values to A, B, and C, then this can never be a triangle. So what I'm going to do is I'm going to label 3 as A, I'm going to label B as 4, and I'm going to label 11 as C. Now, it's always a good idea to make sure that you label your C value as your largest. The other two really don't matter so much, but it's always a good idea to label that C value or as your largest side. Now, in this one, what I'm going to do is I'm going to check that first criteria. I'm going to say 3 plus B, which is 4, should be greater than C, which is 11. Now, 3 plus 4, that's going to be 7 greater than 11. Now, 7 is not greater than 11, so we put a slash through that inequality. It doesn't make a true statement. So because it fails the first criteria, this is no triangle. We cannot form a triangle with this. Now, if we were to take these side lengths and we were kind of to rotate them down here this way, and we were to take this side length and rotate it down this way, these two side lengths would collapse in and it would be just overlapping this 11 centimeter side, and we would have what we would call a degenerate triangle. So it currently has 3 sides. 3 sides are typically known as a triangle if they're connecting. But if we were to move these side lengths down in this fashion like I have here with these arrows, we would be forming a degenerate triangle. So this is not going to be a triangle really at all. Now, in our third example down here in the bottom, we're given a side length of 7. We're given one angle of 30 degrees, and then we're given another angle of 40 degrees. And as you'll see, the side length here of 7 is actually a part of the 40 degree angle and a part of the 30 degree angle. So we call this side length here an included side. Now, if I were to take these lines and I was to extend them out like so, then what you would see is that I would have some kind of triangle. So the no triangle is not going to be one of our options. Now we're down to a unique triangle or more than one. So once again, because of this fixed side, this side 7 centimeters, it can't go larger than that. It can't go smaller than that. We're stuck with that. So because of that, we have what's known, once again, is another unique triangle. We can only form one triangle with those particular with those particular measurements that were given there, the two angles and the 7 centimeter side. Now, in our fourth triangle that we have over here to the bottom right, we're given a triangle with no side links. We're only given its interior measures. We have one angle measure here of 60 degrees. We have another one here of 30 degrees. And then we have our third angle here, which is this squared off area. Once again, it's like this one over here, the top left. When you see that little squared area, this is a 90-degree angle. Okay, so we're given a triangle that has its three angles, but no side links. Now, with this particular triangle, we could enlarge this because we're not limited to what the side links can be, or we can reduce it in size, so we can make it much smaller. So because we have the ability to enlarge this triangle or reduce this triangle, and it still keeps the same angle measures of 60, 90, and 30, whether it's a larger triangle or smaller than this one, this is going to be more than one triangle. So I kind of hope that you're seeing that if we have a side length given to us with a couple angles, we're kind of limited in the types of triangles that we can form. It can only be one type of triangle or a unique triangle. But if you're given no side lengths and you have angles, then what you can do is typically make more than one triangle, and if it can make a triangle at all. So that would be your answers to those four problems.